So how many of you are application developers for the OpenDaylight? How many of you actually have written an application for OpenDaylight currently? How many of you plan to write an application for the OpenDaylight?
Plan doesn't mean immediately, right?
Plan means in lithium, beryllium, boron. Let's focus on 3 next releases. Okay, let's count as an application. Even a southbound plugin counts as an application. Or connector to some other external system. How many of you plan to write a REST application for the OpenDaylight? REST, not, yeah, test. So Java application, or that's a bit different. Okay. There will be always difference writing an external application and internal. And those who already wrote application, have you experienced problems or issues in the APIs? Or are you seeing something missing in order to make your application better cluster aware and better work in the cluster? Yeah, the remote data change notifications will be available. Do you also need, for example, know the master-slave relationship?
Yeah, that I am. We need to know. Yesterday it was discussed, so we need to know which application can interact with which when we are having a cluster environment.
Okay, which application can interact with the switch? So you want your
All 3 applications instances running on all the 3 clusters to write the flows onto the switch. So only one should be aware of writing that.
So one of the requirements is actually your application should be able to collocate or to have a visibility where the switch is located. Who is the master for the switch?
And also when the leadership changes, right? So what will be how the application will come to know? I mean, maybe there is already an API, but the role change of the cluster role, right? Like how the application will get that notification.
Okay, does your application maintain some local state to it?
Yeah.
How you plan to synchronize that state on the mastership change?
Right. So I do thought of 2 ways. Like one is like assuming that the follower becomes leader at any point of time. The MD-SAL data. I mean, we have all the data replicated to the MD-SAL, right?
Yeah.
We can
Read the data from the. Okay.
Notification. There is one mechanism. The other one is like using the remote vCN also we can. We thought like we can update our internal.
Yeah. So one of the problem of the application level clustering is when the application creates a local state. The local state is unknown to the system, and depending on the type of the local state, your application could be easily made cluster aware or migrate through the cluster, or it will be hard for us. So if your local state is actually derived from data change notifications you observed, then you should be pretty much safe, because once you are using the remote DCNs, that state is created on the other nodes, or if you are using normal DCNs and data change notifications, and you get an initial event with original state, so your state will be recreated. In that sense, you are a bit stateless, because you are just maintaining a cache practically in your application. But if your state is created using notifications, RPCs, and based on ordering of that, you need probably, as you mentioned, you need to store your state information into the data store and design that way that your local information could be replicated across the cluster. So that's one of the things which you need to always consider when you are developing the application is, do I have a local state? Is my local state easily recomputable if from data store state? Or is my state created from some other events which are not persisted and are not replayed on all the nodes, which means RPCs and notifications. So for application which maintains the local state, we don't have a solution yet, basically, because your local state could be pretty much anything. If applications writes to the data store, your state is described by the yank, you get all the clustering goodness of that. But if your local state, if application maintains your local state, it could be just the caching. But it's caching of your own data structures you designed, or it could be caching some other different structures which are actually hard to replicate across the cluster. So the local state is a really dangerous thing. Some of them could be automated, could be transferred across the cluster if you provide the correct API and you make sure it's serializable or that way. But we cannot move all the local state. So they will be always, if we provide you API to actually synchronize different state across the cluster, there will be always the limitations where what state you can synchronize across the cluster. And actually the idea of this topic is to figure out how to help you. So other thing is actually how you want to manage the workload of your application inside the cluster. As the application, usually I would put it, there are at least 3 different patterns of the workload. How you do the workload in the application, which is a active standby mode, the simplest one. Then there is a master slave mode. Basically, your master application, your master instances does something, and slaves does some supporting functions only. But the master determines what will be done. But slaves could actually still be used to provision information to the local nodes. So you have an application which is master node, which does, for example, the computation, and use the slaves collocated with the OpenFlow switch masters to push the flows down. That's the other way, actually, how you scale application. Or you could go into the stateless mode, or you could shard your application, where basically you have a masters per some logical sharding element in your application. Imagine if my application is processing the topologies. My application is processing the topologies, and my application could process and correlate different types of the topologies based on the user configuration. I want to shard actually my application based on the topology. So my application have multiple instances, and the instances and for per topology master is collocated with the affected topologies master. So in that case, actually, I'm sharding my application into small logical pieces which could work in parallel because they are working on different data sets. So these affects actually how you structure your application affects how you could perform and your application work in the cluster. The other way is, the other thing you could have is route-to pattern, where basically you have multiple instances and you have one master instance which distributes the workload between these instances. You can have a worker pool pattern. So it really depends what patterns will be common and probably what patterns will be most interesting to the people in order to provide you a good enough API for the use case. So that, yeah, we mentioned that discussion currently in the OpenFlow, it was mentioned that you have basically switch level sharding or switch level masters. And one of the planned extensions for the Beryllium is micro-sharding of the data store. So we could collocate also the master of the data with that switch.
So in this case of switch level sharding, right, like how if an application is registering for a DCN, okay, and if it's just whatever notification on this data tree, just give me the board updates, right? So either in DCN filtering, we can view only on these nodes, give me the updates because if the
So yeah, I see. So currently the data change listeners, when the remote data change listeners will be enabled, the remote data change listener is opt-in API. So normal data change listener API currently available will deliver you events only if you are on the master. So you could still use remote data change listeners if your application is able to receive the data also on the followers. But if you need your application to be notified only on the master of particular shard, use APIs which are already available to you. This will make sure. So you have that power. I want to be notified on all the followers, or I want to be notified on the master. So that's also one tool in your toolbox actually to work with where I will be notified about the change. And we can maybe provide, but in the Beryllium, but this needs to be open as a request, some APIs, which will make maybe that switch of the one listener easier. But yeah, as I mentioned, we need the requirements in order to improve the MDSAL and improve the MDSAL APIs, in order to provide better visibility into the clustering, or better, or make the clustering more invisible, but to use development for you to make your application work across multiple nodes seamlessly, across multiple instances of your application and multiple nodes seamlessly.
Actually, I had a question about micro-sharding. What does it involve? Like, let's say there's a shard, like,
So
switch-based shard. Like,
So currently what in Lithium OpenDaylight support is module-based sharding, which means inventory is one shard, topology is other shard. There is a default shard which is used for all the models. And you could bring up your own shard, by changing the configuration, which is tailored to your model. But that means that all the nodes always belong, from the data store perspective, all the nodes belongs, for example, to one shard. There is one master for one master shard, or master leader for the shard of the data store information. So always, even if you spread across the nodes, the cluster, OpenFlow switches are connected to the different clusters. Their state data are maintained on one node, which is a master. All the commits needs to go through that node, and these data are replicated to the followers. Instance identifier-based sharding, or micro-sharding, is actually it provides you the instance identifier-based sharding. Actually, is based on the path to the data, which is the smallest part of the sharding we can do, and you could build all the other sharding strategies on top of it. So module sharding is just could be re-implemented on top of the instance identifier sharding. But instance identifier sharding, as a feature of the MDSAL, gives the application developers and plugin developers possibility to have, for example, to maintain a shard per switch. So you have a shard per switch, so your data store, so it will go to the point where basically you could have, for different switches, different instances of data store are master.
so let's say we have an OpenFlow switch called OF:1.
Okay.
Okay, we have and our member one is our main node that is talking to us, right? So now OF1 talks to member one, and member one becomes the master for OF1.
Yeah.
But how would member two know that there is a microshard for OF2 or OF1?
So that's the routing function of the MDSAL. So that microshard will be probably implementing using current clustering. So here on the member 2 there will be always follower.
For that microshard.
for that particular micro-shard. So you have that information, but actually this allows you to have, for OF2, you will have different shard, where the layout could be follower, master, follower.
Yeah, leader. So
Yeah, leader, follower, leader. So this actually allows you to improve the scaling, not only the scaling, but to improve the performance. By that, you have the option to have the master per switch, so you could actually make different nodes in the cluster.
so any read would be much faster because you are the master. You are locally on the leader. The master is on the leader all the time.
So any write would be faster.
Right? Wouldn't write still involve like a write?
Yeah, but the write on the master is always faster than write on the follower.
Okay.
The transactions on the master are faster than the transaction on the follower.
There is one less RPC going around.
There is.
I mean, the follower has to first request the master has to do whatever it needs to process.
Yeah, there are a lot of less RPCs involved actually.
So if something changes on the master, the change will populate to the follower later, right?
There is a three-phase commit, so it populates at the same time commit.
Okay, then if I listen on the follower, I should get notification of that change at some point.
Yeah, if you are using the remote data change API, which actually is opt-in because current applications doesn't count with the situation that there are free instances of them. If you use the APIs to listen on the follower, we will support that. So we will get a notification on the follower to receive about that change.
Right, but it's the same change.
Yeah, it's same as which happened on the master, because it's for that switch. So you have still a consistent view of the world, even of the followers.
So why would I need a different API to listen to the local one or the remote one?
So the API is similar. There is one. You will implement same methods. The difference is only in the name of the class, because there are applications which want to work only on the master, collocated, and there are applications which don't care where that notification is delivered. It's about your programming style much more.
Okay, what kind of application would only want to listen on the master?
For example, if I do the workload sharing and my application is written in the stateless way that I just listen on the notification, change something, and write something back to the data store. In that case, I would listen only, my application could run on multiple nodes, and here I can process events for the OpenFlow switch 1, and at the same time I can process events from the OpenFlow switch 2. At the same time I can process events for OpenFlow switch 3. In my application, this application doesn't need to communicate with itself, it stores data to the data store. If I had my application listening on the remote changes, in this use case, all my free instances will be delivered the same change, will compute the same data, and try to write same data to the data store while doing the same work 3 times. And actually, 2 of them will end up with conflicting write. Because already someone wrote that data, and before the data wasn't there, so you will end up with concurrent modification exception. So yeah, so that's why there is possibility to listen only on the master, to not repeat the same work twice or thrice. And in that case, basically, you are scaling your application a bit differently. You are not doing the HA mode, where all the node active standby mode, where all your application is computing the same data here, and just waiting once it becomes master. But you are doing the active mode, where basically my application processes only the data in that particular shard to that particular one switch. Here, the application processes the data for the particular second switch, which is master here. So actually, I sharded my application.
So if the master changes, like this old master died, you elect a new master, the application has to move as well?
The application is running still here, master moved, I'm listening on the master, so all the state which was previously, which was here in the stored in the follower, once the follower changes to the master, all the state is injected into the application. So I can recompute all the necessary information which this application computed.
So just like it's probably an open flow question. So if that old master dies, it will be the open flow switch that will have to figure out the new master.
No, OpenFlow doesn't let the switch figure out who is the new master. That's true. What you mentioned, that's true for the PSEP protocol. OpenFlow protocol is designed that controller decides which instance is the master.
So now that like the remaining two will have to figure out who controls the.
Yeah, there will be a voting, draft, and then probably sending down to the switch I'm master.
And then the application will have to assert mastership of that shard now. Because that shard was originally mastered elsewhere. So they will have to signal somehow that they are the new masters of the shard.
Yeah, that's the API they mentioned before, where you could listen on events who is the master. But if you are using the old APIs, or the old APIs, they are really similar. There is just one, you will implement differently named interface which has a really similar contract. But if you use the old APIs, you doesn't even need to know that application changed, that mastership changed. You will start receiving the events of the master. So if you are using only the data change events, you will not be receiving, and you are using existing APIs of the MDSAL, you are receiving events only on the master node. So your application, if started on the follower node, will not receive any events. So your application does nothing. Once your node becomes a master and you are still using the lithium APIs or helium APIs or hydrogen APIs, your application will receive only the notifications on the master, and it will push to you the current state. So basically, by using old APIs and receiving notifications, your application implicitly knows it's on the master. It's not explicit notion, it's implicit notion. So if your application is receiving events, it's on the master.
So then there is no mastership election at the open flow level. It will just be
On the OpenFlow level, that was what was discussed in previous sessions. They are planning to have a mastership election level.
no, but then Akka might choose a different master, right, for the shard.
For data store shard? Yeah, that's
Micro-shard, right? Like
no. And that's actually one of the ideas if we want actually selection of the micro-shards tailored to some external event. For example, you want really to have a collocated OpenFlow switch micro-shard, the data store micro-shard for particular switch collocated with the switch election master, probably. Not?
Maybe, I mean, but again, the thing is we still have to solve the aggregation problem. Once we solve the aggregation problem.
What's the aggregation problem? There is no aggregation problem.
When you have micro-shards, you have an aggregation problem if somebody tries to read all the nodes.
We have that problem already.
Well, that, I mean, it's not as bad as it will be when
Yeah.
you break up inventory. And the second thing is the data change notifications. Doing it would be hard on the clustering side. Especially if you say, okay, I want to listen to all nodes. Let me know whenever a node gets added to inventory. That's going to be hard.
That's the problem of the sharded data broker.
I know.
Not the cluster.
I'm just,
Cluster data broker.
it's not that, no, but you have to solve it somehow. And it's
Yeah.
still hard.
It's still hard.
You have to solve it or I have to solve it, whatever it is. It's going to be hard.
It's solved already.
It's solved already. And it's very fast. Good.
Yeah.
Go on.
It's just the data structures we are using already, but we will use it also for the sharding.
Okay. No, I just need to understand.
Yeah, okay.
How does it work fast in a cluster?
you are basically increasing the scale of Akka polling and all that stuff with micro-sharding. Would that happen?
No.
Essentially, so you have each and every, like, I think where we're going with the switch, the node thing is, okay, you connected to one open flow switch, and you've got basically one node. Now that node is going to live in one shard, so the tree for that node. So all the table and the flows and this and that and all sorts of stuff. Now, obviously that's going to be, like if I have everything separated out into these subtrees, updating those trees should be faster. I mean, I can concurrently update them, right? Because as they're changing, which is good. Like, the writes will be very
Have you tried to read all the nodes through the REST conf when you have 100 switches connected currently to the OpenDaylight?
Yes.
It's fast.
It's not fast, but this will be even worse.
So Moiz, I was asking a slightly different question. So now that what we have today is like on a module-based shard, Hacker runs this, or like Graph runs the elections to keep figuring out who the master is, right? Anytime. So now if you have split into 100 micro-shards, will there be 100 new elections? Like instead of earlier we had just one election, now you have 100 hello messages, 100 elections.
It would be, but I think that we've thought of ways to actually create something which aggregate with like an aggregate shard, which will do elections. And we
Yeah,
have the-
actually, that's the idea, that the one part of the instance identifier micro-sharding is not you have a shard per switch. You can mark,
you can have multiple
paths pointing to one shard. So you could say distant switches are in shard 1, distant switches are in shard 2.
So again, it's not micro down to the individual switch.
So it allows you to have that, but doesn't enforce you to have that.
multiple nodes in a shard. Think of it. Like,
It allows you to have that. Actually, that's the instance identifier micro-sharding idea is not about we have a shard per instance identifier, but splits a problem into two things. You have a shards, and you have a mapping function which says these instance identifiers, these subtrees are in this shard.
What you are saying is when currently we have like one module shard with one master. We'll take that module shard and split it into smaller chunks with each node having mastership over one chunk each. And then we can put like our data into the local chunk which will make it faster. And if that master dies, that chunk needs to be distributed among the rest. So it's again, you're not like micro-sharding down to the switch level, just chunks, have one chunk per.
we have to be good.
If we
Actually,
put it in need arises, but it's very
Not so each shard would not do its own election. I mean that's what you want to avoid.
so actually, there are two things. The one is the front-end side. The front-end side has a mapping, which allows you to have both types of the sharding, which is I have a shard per switch. That's MDSAL SPI side. You can have a shard per switch if you want to, or you can have a shard which is mapped to 10 switches. So what MDSAL is maintaining is actually, and will be maintaining, is a tree. Instance identifier a tree. And each of these nodes in the tree could point to the shard to which in which they are stored. So this tree could point to the shard 1. And I decided I want a shard per topology, so I can have here topologies in that tree stored. And now we are at the really micro-sharding. Each one points to an additional one shard. So actually this decouples the shards from how you map the data to them. And this allows you to actually create a sharding strategy tailored to your need, and you could have micro-sharding per switch, or you can have a sharding of, you can have a shard per 100 switches, you can have a shard per 1,000 switches, but that's how then that's not the problem of the MDSAL, that's the problem much more of the OpenFlow plugin, or which APIs, how the OpenFlow plugin will decide they want to shard their data.
Tony, did you go over what exactly consumers would have to do as far as like the user of the API?
The user of the API uses the same API.
I mean, they are not using this API, right?
No, this API is for, this is SPI. This is not user level API, this is SPI, which is much more for power users when I want to affect my sharding strategy, or I need, for my southbound plugin, I need this sharding strategy, or for my southbound plugin and my users, this sharding strategy makes sense. So if the OpenFlow plugin decides, for example, to have a shard, to have the number of the shards is the number of the nodes, and it will use and then basically it will decide that, okay, I have 3 shards for the OpenFlow. It actually makes sense to have if we have a 3-node cluster, it makes sense to have 3 different shards for inventory. And you will map the switches connected to switches connected to.
No, here's my, like, here's the thing which I was trying to get to. So most application developers, they don't have to do anything different than
Yeah.
what they're doing today.
They don't have to do.
Now, this, what you're proposing is an SPI.
It's much more of SPI level. Sharding SPI.
Okay, so
That's the
But
micro-sharding SPI.
Okay, but if somebody wants to actually do some custom strategy, then they have to be aware of the SPI.
Yes.
And those are likely to be also application developers. Like if you think about OpenFlow plugin as an application,
Yeah. Yeah.
right?
They need to do that. And the part is that what we are proposing in the MDSAL is SPI, which allows you to do that. Which allows you to do that or that. But that's not common function. That's just a hook for you for the clustered data store or for the Akka cluster data store, which allows you to provide these different strategies for users. So they will use the clustering SPI. So clustering SPI will actually
So how
provide this strategy.
let's say OpenFlow plugin wants to go ahead and do this by themselves, where they want to put each node into a separate
Yeah.
microshard. And so what would the steps be for them to actually get that to happen? Would they
So-
have to define a new strategy, sharding strategy on the cluster data store side?
So on the cluster data store side, they need an API, which is to create a new shard across three node cluster and register that for particular switch. So yeah, they need to create a new cluster strategy.
They have to create a clustering strategy.
Yeah.
Cluster data store should have some API which lets people do that.
Yeah.
But once they do that, then they'll be tied to the cluster data store.
Yeah, that's cost for it. Actually, if you think about that, I am affecting sharding. You are selecting the implementation of data storage. You cannot get around that.
Yeah, but isn't that actually a problem? Because right now, people can write an application and they can switch between in-memory data store, cluster data store, and some other data storage.
So it depends on the type of the application. And yeah, we can figure out that the APIs which will work for single node in memory data store also. The common APIs how to do the sharding. What I am proposing, which is the patches to the controller currently, is that low-level API which makes that possible. It's not the end-user API.
Tony, we already have, there's already a file to configure with the sharding strategy.
Yeah, there is a file. This is not an file is not an API in this view.
But I think that's was the original design.
The original design was that.
Was a file.
Okay,
Yeah,
yes.
see, here, so what would you, when you said OpenFlow wants to micro-shard inventory, so I'm assuming you mean the inventory nodes list, top-level nodes list?
So you want to map an inventory node to shard.
Okay, but OpenFlow's not the owner of the inventory. Anything else, that's just.
And now we are going, and that's why I was the discussion before wanted to have, is why we shouldn't use the inventory
But
model.
regardless, inventory or topology, whatever,
But
Yeah.
if you want to get rid
So it will shard its own topology.
it will shard its own topology. Okay.
Because the topology has a notion of multiple topologies. So OpenFlow can specify sharding for its own topology.
Which is actually still another topic because there are people who say, I want a unified topology.
And we are providing that already.
I
We
know
are topology processing
that's like
framework.
an application. So,
Yeah, that's only application.
okay, forget about this. I think this is a different discussion altogether.
Yeah, well, I don't know, we could find this later, but I guess I still haven't seen a code example of.
Yeah, because I spent the time explaining this, then coding the examples.
Okay.
Well, we missed a little bit, so maybe you're.
No, but I think that's fine. I think this is going to be a learning experience. You're going to code something, we learn from that, and maybe then we can do it.
So actually,
Because right now we have the API.
I like the file-based approach.
I don't like file-based approach. Files are not APIs. For example, that's my personal perspective.
It's a way of configuring the system.
Yeah, and the files,
You do that with your config XMLs, your.
yeah,
your
Yeah, and what the config XMLs are actually doing, they are just shorthand to invoke the APIs.
And so
Yeah,
with a
but-
file.
Yeah,
So
but
with a file.
you don't want to hard code the API. You want to actually read the configuration and then based on that, use an API.
Yes,
That's the way to do it.
that's the way to do
You
it.
should automatically say, okay, I'll tie myself
Because,
to
I'll
custom
tell you
data
why,
store.
because it allows deployments to change their,
I know.
strategy. If you make it file-based, they can contribute that, otherwise they gotta write code.
Yeah, and just to make it in file-based only, I preclude the folks who wants to affect that by the code. And there are folks who want to affect the sharding by code.
Oh, okay, well, either way, yeah, I thought you meant to get rid of the file-based approach.
No, not to get rid. Actually, idea is, and for the clustering, for example, currently, if we have this new micro-sharding API, so how it fills into the current sharding strategies. You load the file, the code flow, actually it's really simple. You load the file, you figure out if from the file there are 3 shards in your configuration. Default, config, no. Default shard, topology shard, and instance identifier shard. This renders actually to 3 micro-shards in the new API, or the 3 shards in the new API, which is the root shard, and 2 shards which are the top level of the topology, the top level node of the topology, and top level node of the inventory. And you register that to the sharded data broker using this SPI. That's the difference, actually. And you also, during that, you create the shards in the cluster data store. But then the netconf comes in. You start the netconf server. Netconf server doesn't want, for example, because netconf server needs to increase the invoked RPC count on each one count. Imagine, or restconf. Restconf monitoring needs to increase the invocation count. If you have a restconf monitoring model, it needs to increase its own invocation count on each and every request in its model. Which means if we are using cluster shard or in-memory data store, means every one HTTP request is commit. For that, probably they would, for the performance reasons, they would want to bring it in on their own shard, which will just render the rest of data, for example. Their own implementation of the data store for their subtree, which will just render the data once they're requested based on the internal counters, or really one shard which is in-memory data store where they could do fast writes and propagate.
About writing your own backend data store.
Yeah, the sharding API, the sharding SPI is also to provide you the SPIs for writing your backend data store. That's why I'm saying it's more low level currently than what's in the code, because this allows you to write your own data store or to provide more fine-grained APIs like clustering strategies for end users. And it solves these 2 issues at the same time.
So like one use where I can think right away is like testing. All this stuff will need to be tested much more deeply than what we have currently. You folks weren't here last evening. We were talking about testing regularly. So one thing you would need probably is a bit more administrative control for a test harness to come in, set things up, and test like various scenarios.
Yeah.
So something like that.
This will actually get very complex.
So that's why we cannot leave it to like chance. Like right now, all follower leaders is chance, and the test, and the robot test has to figure out who the leader is, who the follower is, and then run test accordingly.
Change in the process of the test
So here you will have to first like have more administrative control so that you can test various scenarios easily.
So yeah, in that case, you will probably, we will not run the raft election, but you will bring up the clustering data store in a test where you have the SPIs or exports you some little knob to change the master slave, and you have that administrative control.
That we have introduced already. Like we have a policy, draft policy based on which we can disable election.
There's already patches
Okay.
for that.
Wasn't aware of them yet. Yeah, but yeah, this actually allows you to do the testing, or you could actually, In that case, you could for some switch bring up the,
You'll have to like probably start at the unit test level itself. You
Yeah.
can't, like wait for the integration test to come in. You'll have to do unit testing appropriately for this and then.
So I guess, but you know, then we're taking the leader election out of it, which is a very critical part.
so the SPIs,
That's so I guess you have different. I'm talking about. Sorry, we're getting off track. But testing.
You will have to discuss testing when you are introducing something as complicated as this.
We don't want to lose testing leadership because if you do that route policy, you take a leadership election out of it.
Then you have to
Then you have no test
specify.
for it.
You have
What you really want is a longevity test where you do a, you know, get a leader election. Say in over 8 hours, that leader should never change. Anyway, but that's
yeah,
getting off.
there are different things we need to test.
Yeah.
Really different things.
Yeah.
But again, my thing is we should keep testing discussions as part of this. We cannot push them off for later. But there are important
Yeah,
considerations.
for all this stuff, we should get in the habit of figuring out how we're going to test it. And writing integration tests along with it, because that's usually how you do it.
Because I think
I think I have a better understanding.
Explain.
You want to, maybe another
Could you,
perspective.
yeah,
I
could you
do-
explain that in
In your way, I think.
in
I
your
do,
way?
But I would like.
Yeah, and actually explaining it in your understanding is helpful because I can see if I miscommunicated.
Okay, so let me make my points here. I think, see, the SPI has nothing to do with really micro-sharding at all, in fact. All it says that I mean, it could be used for micro-sharding, but all you're doing is you're saying this Yang instance identifier, the data for that will belong in this shard.
Yes.
You can go ahead and specify that. And what it lets you do is now, just if you want to have a shard, where you want to have a bunch of information, totally unrelated even, you can go ahead and do that. Today, I can't put inventory and topology data into one shard. With this SPI, that's going to be possible.
So we could put the OpenFlow topology and OpenFlow inventory into one chart.
And the other thing is,
Not that you want to do that, but.
You, for example, if you are running just OpenFlow application and you are just OpenFlowing in the inventory, and you have the OVSDB topology, you want that maybe separately, but you want the OpenFlow topology, which is learned by the LLDP, and export that in one chart. Maybe, maybe not. Depends.
Anyway, but it'll,
Depends on deployment usually.
second thing is, for most application developers, the API doesn't change. I mean, they are not aware of this. This is not a problem for them. Producer-consumer API has nothing to do with that. So we don't need to worry about that part. And this is a complex API that's being introduced. Right? The other thing is, we can have multiple data stores under the same logical tree.
Yes, that's the idea.
Which is another,
That's data tree sharding. That's why it's called data tree sharding. You have multiple data stores under one logical data tree.
correct. And which is something that we wanted. Like, you want to have something in memory local. For BGP, I think that is a good case. And then we want to have all the statistics data retrieved from Cassandra, which I could do that now. And whatever we do with the clustering, then we continue to do that as usual. Nothing changes. In fact, I think
no, that makes it very flexible. So
Yes.
It's okay in your own
So-
SDR, whatever.
Yeah, really you got the concept. The concept is the data broker is not tailored that there is one data store implementation. It provides you a data namespace and gives you an APIs which lets you to specify where to fetch that data. So TSDR could be integrated directly, and you will access it as a normal NDSAL, even if it is backed by Cassandra. The other thing which maybe allow you, when you are doing the integration with the customer system, you need to have a Yang model, for example, and you need to have a Yang model of the subscribers. And your customer requires you to actually have that subscriber information stored in the SQL database. You will bring the SQL backend, or you will write small plugin which will go and fetch and read data from the SQL database, connect to the Oracle SQL. From the MDSAL application, user still sees it as it was originally stored in the cluster data store. So this allows you this is Also for developers to actually bring the connectivity and export different systems in the data tree, into the Yank data tree, but also for integrators to connect with various data sources more easier once the requirements will pop up. And you will see that people in the enterprise or SPs will not be comfortable just storing every data in not the cluster data store. They have their own requirements. All the data needs to be stored, or all the user data needs to be backed in our server disk, which is monitored, and so on.
So that is all the flexible part. Here's what actually got us all confused. Because what we started off saying is there will be no reads. You need to have data change listeners, and
That's the different part of the story.
okay, now explain that story. I mean, how does that affect users?
So the story behind these are about new proposed Beryllium APIs. The story behind having a reads and don't having a reads and having the data change events. Once you introduce this strategy, it's harder to do reads. That's what you asked. Reads will be available. Reads will be available, but the cost for the read is even now the cost of the read is sometimes larger than it seems, and it was in the in-memory data store. The read in the in-memory data store, if you are running in the single node,
No, it depends.
it depends.
If all your shards are local, it's going to be about the same as in memory
Yeah.
data store. If the leaders are local,
Yeah, if you hit the multiple shards, it's a problem.
it's not that much of a problem.
Yeah,
This one. Anyway,
yeah. But the idea, there is a new set of the APIs proposed. If we are discussing these APIs, I may have something to share about that.
I think that's the part which is we don't like. Sharding API, I think, is okay.
Yeah, the sharding tree API, I think is
I mean, we don't
straightforward.
understand. Sorry,
No, we don't.
I shouldn't say we don't like.
We don't have a
We don't
full-
understand.
We don't have the full story.
Yeah.
So the other part of the APIs,
We don't know if we don't like the
you will like them.
No, because that is more consumer facing. Am I right?
Again, whether it's like, will this proposal be like documented on the wiki somewhere?
See,
Those who are
it's
not-
already well documented in the code. No, I think
APIs are there already.
there has to be some.
Oh, yeah.
Yeah, and what?
Well, it may be in a wiki, but how do you find it? That's another story.
And that's why I want to move out from the wiki and actually have this proposal hosted in the repo, and all the documentation hosted in the controller repo, so you have code and documentation in one place. But that's the different story.
Just find yourself a Googling expert who can
No.
formulate the right query for you. So
We suck at one thing, which is we have a lot of documentation at a lot of places. Hard to find.
contradicting documentation.
That's why if you have it in one place, reviewed,
Did we get the best stuff on it?
yeah, contradicting because it depends on who wrote it and who reviewed it.
And at which time?
In which time, who reviewed it, and who wrote it.